So integral defined functions used to be the darling of the um, test development committee for calculus, and I like them rather a lot, which means they don't show up as much as they used to. Once upon a time, they were very regularly on the AP exam. Now, sometimes yes, sometimes no. Almost always you'll get asked several questions that involve the fundamental theorem, and this is one of the ways they can ask questions about the fundamental theorem. So let's take a look at this one. It's got all kinds of stuff going on. The graph of f shown below is continuous on the closed interval from 0 to 8 with horizontal tangents at x equals 3 and x equals 6. So it just lets you know that those are indeed high points and low points, and there's no hinky business going on. That's hidden behavior. Let h of x be the integral from 1 to x of f of t dt. Okay, so they're defining h in terms of the integral of f of x, which is shown down here. So first of all, it says find h of 1. Well, for a problem like that, all we're doing is we're replacing the x with 1. So h of 1 is the integral from 1 to 1 of f of t dt, which, because we understand what we're doing here, is what? 0. Is h of 0 positive or negative? Justify. Okay. Well, h of 0, again, just using the definition, is the integral from 1 to 0 of f of t dt. Most people do not like that when you go from a larger lower limit of integration to a smaller upper. And I get that. I mean, I always have to think about it. So the first thing I would do is make this the opposite of the integral from 0 to 1 of f of t dt. Between 0 and 1, is f positive or negative? It's positive. Since f is positive, on the open interval from 0 to 1, the integral from 0 to 1 of f of t dt is also positive. So the opposite of the integral from 0 to 1 of f of t dt, which is h of 0, is negative. So far, so good? All right. Now, what is the x-coordinate for which h has a maximum? Forget about this being defined as an integral. Just think back to when we were trying to find maximums and minimums. What is it that we did? We looked for critical points by taking the derivative, right? So, and since this is a closed interval, we can use the candidates test. We already know some things about it, but we'll go on. So I'll take the derivative first. H prime of x by the fundamental theorem is f of x. When is f of x equal to 0? Well, equals 0 at x equals 1, x equals 4, and x equals 8. So, and I should have left more room for this. I apologize. I'm going to do a table of values out here. X, f of x. So my candidates are 0, 1, 4, and 8. we know that h of, not f of x, my fault. I want to know about h of x. Right, because I'm trying to find the maximum or the minimum of h. Well, we know h 0 is negative. That was already given. We don't know exactly what its value is, but we do know it's negative. What's h of 1?
0.
0. What about h of 4? The integral from 1 to 4. We know it's positive. And this is why on this particular one I didn't ask you to justify it, because it would be difficult to explain precisely. But is it pretty clear that this area far outstrips these two areas added together?
Yes.
Yes. So then the positiveness that we've gotten so far from 1 to 4 is far outweighed by the negativeness that we get here. So this is going to be negative. So the answer is x equals 4. Then we want the x coordinate for which h has its minimum. Okay. So h of 0 is negative, and the amount is equal to this little slice of area that we have here. H of 1 is 0. That's not particularly helpful. H of 4 is positive. And then H of 8 is negative, and it's the difference between this area and this area. Do you think that's more than this little area right here?
Yes.
It's quite a bit more. So x is equal to 8. So while this makes a good discussion question for in class, it makes a crummy AP question, because they would have to be able to ask you more than that. Now, it would make a good multiple choice question, because you don't have to justify it. Then it says, find the x coordinate of each point of inflection of y is equal to h of x. And your first thought might be, oh, I need to take the second derivative of h. Not true. Remember, a point of inflection is where the graph of h changes from concave up to concave down, or concave down to concave up, right? By definition, concave up is on any interval where h has a derivative that is increasing, which means that h prime is, pardon? H prime is just positive. So every place that h prime, which is the graph of f, is positive, means that all throughout here, h is concave up. And after here, I'm sorry, hang on just a second. I drew that really badly in a place where you're like, what the heck? So remember, this is f, but it's also h prime, right? So where the derivative is decreasing in this little segment, h will be concave down. In this little segment right here, h is concave up because h prime is increasing. What's happening here in terms of concavity of h? Yeah, so you have to be careful about it's decreasing, because you're like, which is decreasing? Because there's lots of functions going on here. So h prime is decreasing, so h is concave down. And that continues all the way from here to here, right? And then on this last part, since h prime is increasing, h is concave up. So those are the locations of my point of inflection. X equals 1, X equals 3, and X equals 6. And you don't need to go through all of that mentally to find the points of inflection. If you're looking at the graph of the derivative, maximums and minimums of the derivative are inflection points on the original function. Yes? Yes. So hang on just a second. Any other questions about E? Everybody get that? All right. So for D, so H is negative here and H is negative here, right? So it can't be 1 and it can't be 4. All right. So what is the value of H of 0? Well, it's equal to this area but negative. What is H of 8? It's equal to this area minus this area. This is so much bigger than this area that although that's negative and the sum of these two will be negative, this is way more negative than that is. Okay? All right. So flip over. Let's look at free response questions. So the continuous function f is defined on the interval from -4 to 3. The graph of f consists of 2 quarter circles and 1 line segment as shown in the figure above. Let g of x equal, oh gosh, it's not just an integral defined function, they've tacked on a plus 2x just to raise the degree of difficulty.
I don't like that.
Okay. So then it says find g of -3. Okay, that's actually not hard. G of -3, you're just using the definition. It's 2 times -3 plus the integral from 0 to -3 of f of t dt. That first part is -6. Nobody likes this when it's 0 to -3. So I'm going to go, okay. I'm going to switch it and change the sign, make it minus the integral from -3 to 0 of f of t dt. The integral from -3 to 0 is just that. It tells you that it's a quarter of a circle. What's the radius of that circle? So its area is 9 pi, so 1/4 of that, 9 pi over 4. So this is -6 minus 9 pi over 4. I think you got a point for doing that if I remember this one correctly. Then it says find g prime of x. Okay. Taking the derivative of 2x will be 2 plus f of x. I think you got a point for doing that. And then g prime at -3 is 2 plus f at -3. F at -3 is 0, so that's just 2. All right, everybody good with that? All right, then let's look at this next one. Determine the x-coordinate of the point at which g has an absolute maximum on the closed interval from -4 to 3. Justify your answer. It's an absolute maximum. It's a closed interval. We're going to use the candidate's test. We already know 2 of our candidates. Are -4 and 3. We need to see if there are any other candidates for this. And I think this, to me, was the part where I'm like, oh gosh, I have to think about this. Well, I know that g prime is 2 plus f of x. If 2 plus f of x has to be equal to 0, that implies that f of x has to be what? Negative 2. Negative 2. Somewhere down here. And usually, honestly, they make it a little easier, but you're like, it's somewhere between 2 and 3. I could guess that it's 2.5, but I'm not absolutely certain that it's 2.5 right off the top of my head. You're like, well, how do I work that out? Well, if you want to, you can write the equation for this line. You know it goes through the point 0, 3, and through the point positive 3, negative 3. So I can find the slope of that line. So the slope of that line would be, goes down 6 over 3. Slope of that line is negative 2. So the equation of that line would be y is equal to negative 2x plus 3. And I want to know when that's equal to negative 2. And it turns out to be exactly what I thought it was. It is 2.5. But it's not always immediately obvious on those. To me, that particular part of this was just a time suck. Right? I'm like, this problem already takes a long time. Having to jump through that particular hoop irritated me. So this is 2.5. All right. So now we want to evaluate g of x at all these points. You're like, great. So are there any of them that we can do really quickly and really easily? Well, not really. Although we can do at 3, from 0 to 3, and this is where they gave you some time back. The integral from 0 to 3 of f of x dx is 0 because these two areas are identical. Plus the 2 times 3 makes that 6. Okay? All right. At 2.5, we're only going to here, right? So I can't do the same thing, but I can work it out. G at 2.5 is going to be 2 times 2.5 is 5, plus this integral, which is the area of this triangle, is half times 1.5 times 3. Yeah. And then I was mad again. I was like, really? That's 2.25 plus 5 is 7.25.
Can you just subtract the other triangle as well?
Oh, sorry. Thank you. Minus the area of this triangle, that's half times 1 times negative 2. So is that 1?
Yeah.
So this is 6.25. Thank you. And g of negative 4 we've already done a lot of the heavy lifting for that because g of negative 4 is going to be 2 times negative 4 plus this integral from 0 to negative 4. Well, we've already worked out the integral from 0 to negative 3 is negative 9 pi over 4. And this part that's below the axis, but we're going from right to left, is going to be accounted as positive because it's below and we're going the wrong direction. So that's just pi over 4. So this is negative 8 minus 2 pi. Clearly not a maximum. So the x-coordinate is at x equals 2.5. Yeah. This is not my favorite one. There are other ones that are less cumbersome than this one. Yes.
On the g of -4, why times 2 times?
Because that's the very first part of the definition. No worries. And that's part of what made this hard, is you had to think about that also. All right. So then find all values of x on the interval from -4 to 3. Notice that not including -4, not including 3. Pay attention to intervals. Sometimes that will make your job easier. For which the graph of g has a point of inflection. All right. Well, we know that g prime is equal to 2 plus f of x. So if we add 2 to this, what does it do to the graph? If we add 2 to f of x, what does it do to the graph? Yeah, it just moves it up 2 spaces. So this changes from increasing to decreasing only at x is equal to 0, right? At x equals 0. Therefore, our answer is x equals 0 is a point of inflection of g. Let's do one that's not quite as nasty. I'm sorry. I'm sorry. Oh, sorry. I forgot to do part D. Didn't see it. Thank you. So for part D, now that I've scribbled all over everything, find the average rate of change of f on the interval from -4 to 3. Well, that's pretty easy. The average rate of change, this was a long problem, is going to be -3 minus -1 over 3 minus -4. And you don't need to do anything to that. In fact, please don't. Nothing good can happen from this point on. You've already gotten the point. It says there is no point C between -4 and 3 for which f prime of C is equal to that average rate of change. Explain why this statement does not contradict the mean value theorem. So why doesn't it contradict the mean value theorem?
It's not differentiable at 0.
Yes. F is not differentiable. At x equals 0, therefore, the mean value theorem does not apply to f. on the interval from -4 to 3. All right, let's see if we can do this one a little faster. Like I said, it's not as cumbersome, but I wanted to show you that they can get ugly sometimes. All right, so I'm going to start with this a little smaller, and I know that that's hard for you to read, but you can read the one on your paper. So the graph of the function f, consisting of 3 line segments and a quarter of a circle, is shown above. Let g be the function defined by g of x is the integral from 1 to x of f of t dt. So none of that 2x business on this. The one thing to notice, though, is they started at 1, not at 0. That actually got some people in trouble on this. They're just so used to starting them at 0 all the time. So find the average rate of change of g from x equals -5 to x equals 5. Well, that means we need to know what is g of 5 minus g of -5 over 5 minus -5. And that's your average rate of change. So g at 5 would be the integral from 1 to 2, 3, 4, 5, all the way to here, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm just counting squares. Everybody good with that? Hopefully I counted correctly. Minus g of -5, well, that's a little uglier. So notice I'm going backwards, right? I'm going from 1 to -5. And all this is below the axis. So all that's going to be positive. So I've got this little triangle right here whose area is 1. I've got this quarter of a circle with a radius of 2. So its area is going to be pi. Plus here I've got a triangle that's 3 by 4, so that area is 6. Over 10. Again, don't do anything to that. It will not help your grade. It could hurt your grade, but it will not help it. By the way, right there, that was worth 3 points out of 9. The rubric is on the back. Then part B, find the instantaneous rate of change of g with respect to x at x equals 3, or state that it doesn't exist. Well, the instantaneous rate of change is going to be g of x. Excuse me, g prime of x, my fault, which is equal to f of x. So at x equals 3, the instantaneous rate of change is g prime of 3, which is f of 3, which is 4. That was only worth 1 point. Yeah, I would have made it 2 and 2, honestly, but they didn't ask me. All right, part C. On what open intervals, if any, is the graph of g concave up? Okay, again, think about the definition of concave up. A function is concave up where its derivative is increasing. So this is g prime of x, right? G prime of x is equal to f of x. Where is f of x increasing? From -5 to -2,
0, 3.
and 0 to 3. Justify your answers on these intervals. And I always just say it every time I use it, although sometimes you can get away without saying it again because you've said it in part B. G prime of x, which is equal to f of x, is increasing. How did they word it? Oh, pretty much exactly like that. And then find all x values in the interval from -5 to 5 at which g has a critical point. Classify each critical point as the location of a local minimum, a local maximum, or neither, justifying your answers. Okay, so critical points are where g prime of x, which is f of x, is equal to 0. Notice again, it's the open interval. I don't have to worry about local minimums or local maximums at the end point. So that's going to be at x equals -2 and x equals 1. At x equals -2, do we have a local minimum, a local maximum, or neither?
Neither.
Neither. Because g prime does not change sign. At x equals -2. And at x equals 1, what do we have?
Minimum.
Yeah, we have a minimum. Because g prime changes from what to what?
Negative to positive.
Yeah, negative to positive. That's a very straightforward one. The other one is a very not straightforward one. Most of them are somewhere in between these two. The other one took a lot longer too, and then they threw in this, other parts, and I'm like, oh gosh.